right, good morning everybody. How you doing today? Let's flip this over. Just got to double check that we are live on Twitter as well. We're live primarily. Yeah, we are. Perfect. Good. So that's working. Awesome. Always a good thing when the stream works first thing, which is nice. I'm taking comments on LinkedIn. We're taking comments on Periscope as well. I think I've got this set up so it shouldn't be a problem. If you guys want to catch up on previous streams, you know that we've got it all set up on my website. I dropped a link in both streams here. Previous streams at... There you go. Now it's in both of them. So you can catch that up. You can see there. We're going to be talking today about misconfigurations and mistakes. And there's a reason why I wanted to bring this up today. I think it's a really important topic. I think it's a place where a lot of people fall down. But last week, you guys know, I was at AWS, or not AWS, dear Lord. I'm already in reInvent. I was going to say AWS reInvent. I was at reInvent last week. No, I was not at reInvent last week. I was talking and thinking about reInvent last week. But where I was last week was at Serverless Conf in NYC. It was really fantastic. Great crew, awesome community. It's amazing how the serverless community has exploded over the last few years. Can't believe that was already the 9th serverless conf over 3 years. We were talking about a bunch of stuff, and I gave a talk there on security as normally I do, and I got some interesting feedback. So I'm just adjusting my windows so that I can see all of your wonderful comments. So again, if you want to comment on LinkedIn, if you want to comment on Periscope, I should be able to manage those live. I think I've got this down after the sort of semi-catastrophic upgrade to Catalina. Of interesting note, I complained about some issues about macOS online, and Apple support actually pinged me right away and said, we want to call and talk to you because you found a bug, and it's a bad bug. But so here's what I'm going to do. I'm going to flip over to Google Chrome. I'm going to show you something. So this is the page. I put the link in the description already or in the comments to talk about the previous stream. So you can look at all the previous streams here. Also the talks. I'm giving 2 talks. Sec 204-S is sort of my annual thought leadership, which I hate as a term, but it's basically, every year I try to give you something new. This year, I'm kind of putting all the pieces together for security. Also hosting a customer talk, DOP 204, so DevOps 204. Got a great customer in Pivot, Jason Kraditz, fantastic guy, great speaker. He's going to be talking about his journey. So we're doing the stream right now, but you can see the previous stream. So we did the live reserve seating. You can watch that. You can watch serverless. We talked about the basics of that. But as a result of going to serverless conf, I actually fired up a post, and I already shared it on LinkedIn. I don't think I shared it on Twitter, but I'll do that soon, where I talked about what's happened over the last few years in serverless security. So I started researching this really heavily at the beginning of 2016, and here we are 3 years later. And essentially, originally I proposed these areas of serverless security. So flow of the data, choosing the services and APIs you're using, code quality, and monitoring production. Cool sound effect, fast forward, and here in 2019, we've adjusted that based on a few years of seeing things play out in the market. And we've got service selection still. You need to make sure, if you're handling healthcare information, your services handle HIPAA data, things like that. Code quality in your functions, the data flow between your services that you're stitching together, then configuration validation. Now, configuration validation is to tie into the problem that we're talking about today, which is misconfiguration. So if you look at how I wrote up the talk, I'm just going to scroll to the bottom here. Please bear with me as I scroll. I thought the talk went really well. I tried to do it a little more personal. What I talked about here is that the number one threat in serverless, and really the number one threat in cloud today, is misconfigurations. People are making simple mistakes and exposing data needlessly, which is unfortunate. So if we take the risk of going to Google, all you need to do is type in S3 data breach, and you look what happens. You get millions of results. Now, there's realistically, there is just a finite number of these things. There's not millions of S3 data breaches, but we've gotten so many at this point where leaky buckets has, from Business Insights here, the 10 worst Amazon breaches. If you're at the point where misconfigurations are such a problem that you have top 10 lists, this is something worth diving into, and that's what we're going to talk about today. So the first thing we're going to do is we're actually going to dive into our AWS console. Now on this, what I have is I'm logged into my console and I've gone into services and I've typed config, AWS config. It is probably the most ignored service, if we can say that, outside of SimpleDB, which is a hidden service. This is the first setup page, and essentially what config is a compliance tool. Now you can customize config to pull in third-party information, but by default it pulls in AWS information. And what it's doing is it's looking at the CloudTrail logs to give you the state and time of anything that's happened in your AWS account. And that can be really, really useful. So we have not set it up in this account before, so you get this initial page. What are we doing? Well, we're going to record all global resources, including the ones in this region. We are going to create a bucket. We're just going to create a bucket and we're going to call it the default. That's fine. It's AWS config, blah, blah, blah. Are we going to stream these configurations? No. So you could automatically stream these to an SNS topic, which gives you the ability to sort of automate things even further, which is really cool. I like that, but we're not going to do that today. And we're going to let it config, set up the rules that it requires, and then we're just going to hit next. So now we have the option to add rules if we want to. We're going to skip this. And we just hit confirm. And now AWS config is set up. So it's now tracking CloudTrail as changes are made. Now this is a demo account. Not much actually happens in here. So we're going to fire up something so that we can see what config actually does. So now config is set up. It's unable to assume the role. That's always challenging, but it's redesigned. Let's flip over to the new look. There we go. So we're in the new look console. So right now we have nothing. We have no resources anywhere doing anything. So what we're going to do is we're actually going to fire up EC2. I'll open it up in a new tab to make life easier. And we're going to launch an instance. This is very basic, very simple. We're just going to launch an EC2 instance only so that we have something in config to do. So here I don't even care. This is locked down with a security group, so it's not doing anything. It's just going to spin up a server. So now this is launching, which is great. Now the challenge here is that because AWS config works off of CloudTrail data, it has to have that data in CloudTrail in order to actually do anything. And that's the real problem, is that CloudTrail has no defined SLA as to when it will drop information into your S3 bucket into CloudTrail saying, hey, you launched a new instance. Now, based on experience, depending on the volume of transactions in your account and the size of your account, this could take 2 to 4 minutes. So while this is going, I'm going to flip over to some slides and show you a talk, part of the talk that I always give or have been giving at summits this year. Thankfully, summit season is over, so I don't have to run around like mad anymore. This was on automating advanced security automation made simple. And the thing that I wanted to call out to people was that when you're doing automation, and this is what we're going to do to make sure that we're catching our mistakes, you need to realize there's a fast lane and a slow lane. Now, the slow lane is through CloudTrail, which is what AWS config builds on. And then there's CloudWatch events, which is the fast. Now, you may say, well, why don't I just put everything in fast? Really just keeping track, right? You're going to hit some Lambda limits if you're trying to do stuff. You're going to just have overhead where keeping everything in AWS config makes sense, and you'll see that in a second. So the idea here is that, and the reason why we started with this is the idea is you're going to make mistakes and you're going to have misconfigurations. And there is a number of things you can do to prevent people from taking actions in the AWS cloud, and that's what we use identity and access management for, and that's a whole nother topic. Thankfully, AWS just hired its first developer advocate for IAM, which was an amazing move on their part. But what we have is we have the ability to prevent people from doing things, so Mark does not have the permission to spin up an instance. That's a really simple way to stop a misconfiguration, and that's the absolute first thing you should be doing, is applying that principle of least privilege. I even have a slide for it. Excuse the scrolling. Because that's there we go. Principle of least privilege. Grant only those privileges which are essential to perform the intended function. So if I have a job and that's simply reading one file out of S3, the account I'm using should only have the ability to read a file out of S3. I shouldn't have to list files. I shouldn't have to write them. I shouldn't have access to EC2 or DynamoDB or any other AWS service. I should have just the permissions I want. Now, a lot of the time, people don't do that. People apply a ton of extra permissions, and I get it. Trust me, I totally 100% understand why you do that. So this comes back to what we're talking about today is misconfigurations, right? Mistakes and misconfigurations. So your ideal approach here is stopping people from doing stuff in the first place. So prevent them from doing anything bad by simply locking those permissions down. That's the first thing. So prevent the mistakes, right? That's the easiest mistake to fix, is the one that you don't make. Reality is you're going to make a ton of mistakes. And that's what most of these S3 breaches are, is that they were mistakes. Because by default, something, when you create a bucket in S3, it's locked down. It's completely locked down, and only the person who created it can do anything with it. You have to explicitly add permissions, which means every time you've seen a big headline that says, oh, another 1 million or 10 million records exposed in S3, someone made a mistake. Someone made a misconfiguration. So what we are going to do is set up some automations to catch those misconfigurations. In the first place, we wanted to start with AWS Config because that will allow sort of this slow lane look. So things that you're like, it's not urgent. If it happens, we are okay for a few minutes, under 10 minutes, we can catch that and fix it. That's great. So those are the we'd prefer. If you were doing policy-based language, that would be, you should not do this. Right? So you have the option to kind of sweep up and say, hey, Mark, you did that. Are you really sure you're supposed to? Or you could take a corrective action. Now, the fast lane you see up here with CloudWatch events is the you must not do this. Right? So you have the ability to intercept very, very quickly in near time. Think seconds on the top, minutes on the bottom. So you act accordingly, right? Now, if we flip back into our browser here, let's see if this has done anything. And this is the sort of challenge we have, is now our instance is up and running, which is great. I don't really care about it. It's literally just there to show us something. And we're going to refresh config to see if config has found it yet. Now, again, config works off of the data that's sitting in CloudTrail. So you can see here in config, it's already found some security groups that exist, but it doesn't have our EC2 instance yet. So let's see if we can find it. We'll see if it's there. Oh, and there it is. So that should be our EC2 instance. Let's just double check E36. So you see here, I'm looking at the instance ID, the last three characters, E36. So this tells us everything we need to know about our EC2 instance, right? This is a really, really handy way to visualize. Let me get rid of that. To visualize what's going on in our environment. But if we go back to the dashboard, you'll see that we have the ability to add compliance checks. We have the ability to add custom rules to say things like, I want this EC2 instance, this EC2 instance, this thing should always have a tag. Right? So I should always have tags, and I don't have tags. So I can create a rule that says, anytime you see an EC2 instance that doesn't have tags, fire up and say that you're non-compliant. Now, because this is a compliance tool, that's what the framing is always. Are you compliant? Yes or no. So it's looking for yes or no answers. You can also create custom rules, which means if you have like a security tool, we did this as a Trend Micro project originally when config launched, we had a rule that said if deep security, which is our security product, if it wasn't running, send up non-compliant. If you have a certain log configuration, you say, you know what, I want all my logs going to Splunk or going out to Sumo or something like that, you could have a configuration rule that says every time you see a new instance, run this rule, check for this piece of, for this data, for this flag, and if it isn't, flag this back as non-compliant. Now, config used to have a really beautiful visualizer, and I think it's gone, which is unfortunate. There we go. Now we got some resources populating in. So you can see these resources, and if we click on the VPC, this might be where they hit the, see, they got rid of the visualizer, and that really sucks. Because the visualizer was amazing. So this gives us our ability to look at what's going on, and we can query against our data. Let me just do a quick Google for a second. Because that visualizer, visual config view. There. Okay. So I don't know how to get to this right now. I can't remember. There's a configuration. I think it has to happen after time. But essentially, you get this really great view of, okay, on the 17th, here's what happened. There was one change and one event. Earlier in the day, here's what happened. And this is really important. This is why I wanted to show you config and the challenges of live streaming when you don't prepare enough ahead of time, because there's something else I want to show you as well. So I looked into that instead of this. Now, this gives you the ability to check into how things have changed over time. It gives you this nice timeline, and you can click on each of these time events and say, okay, at 1:20, what happened? And it'll give you a list of exactly everything that happened at that time, and you can actually click on the compliance timeline and see yes or no if these things were in line with what you expected. So that's one way that you can catch misconfigurations, or if somebody makes a mistake, is through compliance. However, remember this, and I'm going to be flipping back to this, I think, a lot. Remember this fast lane, slow lane. Everything takes time in config because it's based off CloudTrail. So that takes time when there's a challenge. Now, what we're going to do is we're actually going to hook a CloudWatch event. We're going to set up an event, and we're going to trigger a Lambda to do something. And what we're going to do is we're actually going to fire off for when instances are shut down. So instead of going in AWS Config, we're going to go to CloudWatch. Now remember, CloudWatch, unfortunately, is actually 3 services. There's CloudWatch Metrics, which you're used to, CloudWatch Logs, which is a really fantastic log tool, and CloudWatch Events, which is what we're going to use right now. So we're going to go to Events. We're going to get started because I've never set it up in here, and we're going to match a pattern. So instead of doing a scheduled CloudWatch events is like a cron job on Unix or Linux. It's basically every X number of minutes or every hour or whatever. What we're going to do here is actually look for an event pattern, and we're going to say EC2, and then the event type, we're going to get a state change notification. So anytime a state changes for an EC2 instance, we want to get notified, or we want to see this set up. And in this case, what's going to happen is it's going to send this detail type of the event pattern to us. If we look at a sample event, let's scroll down here so you can actually see this. So here's a sample event, right? It'll say the ID, instance change state notification, the account, US East, which resource, which is our EC2 instance ARN, right? So that tells us exactly which EC2 instance, and then what the status change of it was. Now that's really cool. So we're going to hook into that to prevent something from happening, right? So Jawad has a fantastic question over on LinkedIn. So he's talking about multi-account environments. Now, multi-account environments are really, really tricky because the AWS has a very simple principle of your data needs to stay in region in the account that it was. And then it gives you the ability to view it sometimes from other areas depending on the service. So that's called a master member pattern, so that every member has its own data. So if you have Mark's account and you were looking at CloudTrail sitting in the one area, the question is, can you pull out from other areas into config? Well, config mirrors the CloudTrail data. So you can look at, I believe in config, you can check within that same account. The problem is going across accounts. Now you have cross account roles that you can assume. It is possible to set it up to look at different ones from config, but this is also why config has the SNS topic output. So if you set up config and say anytime there's a configuration change, send this to an SNS topic, that topic can be in your master account, and then you can subscribe to do things in that master account, because the config rules are just Lambda functions that take config events. So you can have that. Yes, and thank you, Steve. Excellent point. I did not switch back to Chrome. So when you have that multi-account setup, you get into a lot of this plumbing for cross-account roles. There's some documentation that I'll fire into the comments afterwards that will help explain that. So as I had this hidden, I'm going to explain this again really, really quick. And thank you, Steve. I very much appreciate that. Managing the multiple windows is somewhat easy sometimes, but it needs to be after coffee, not before. So what we've done is in CloudWatch events, we've set up a rule and we've said event pattern, because we want something to happen And if that happens, then we want to match. So in this case, we selected a service name. We said EC2. We don't want all events. We just want when an instance changes. So what we're going to trap here specifically is someone pauses our server, or if someone terminates it, we want to know. And so we're going to say any state, because we don't want to. We want to catch multiples, and we're going to say for any instance. So if you scroll down, you get a preview of what that looks like. And you get actually these sample events. Now, most of the stuff you can just ignore. The detail type is kind of handy because we can filter on that in our Lambda function. But the resource is the important thing. That's the specific identity of the instance that's been changed. And then you get that again in the detail instance. In this case, it's going to be pending. So what we're going to do is we're going to copy this over, and we're going to go to the right-hand side. Go to the right-hand side, and we're going to add a target. And in this case, we're going to add a Lambda function. We're going to change this reinvent sample to be what we want to be. Configure the input as a matched event, which is perfect. So what this says is essentially anytime we match an event on the left-hand side, so anytime EC2 sees a state change, we want to trigger road to reinvent sample number 1. Right? Very simple. So we're going to add that target. Oh, wait. We always add that extra button so you can add multiple targets. We just want the one target. We scroll down to the bottom, and we are going to say confirm. So this is our rule, EC2 instance changing, and we're going to enable this. So we create the rule, and now anytime an EC2 instance changes, it's going to trigger our Lambda. So let's whip over to Lambda real quick. And we're going to go to our function. Now this function was what we used earlier, and you can see now it's wired up to CloudWatch events. That's the step we just took. CloudWatch events is going to trigger this sample, and it has access to Amazon CloudWatch logs. And we're going to change our code because we had this code running earlier. So what we're simply going to do is we're going to dump out the event, and we're going to return nothing. We're just going to return a 200. So basically what this happens is this is our Lambda function. It says when we're triggered, so when EC2 instance changes, all we're going to do is we're going to take the JSON document, and we're going to dump that entire thing out to the log. So we're going to just print out what it was sent just to show that it's triggered. Now what you would do here normally is you would take some sort of action because somebody's doing something you don't want, right? They're making a mistake or they're making a misconfiguration. Now let's just save this real quick, and let's run a quick test, and you'll see it just dumps out whatever was sent to it. In this case, we had an S3 example. Let's add our new test event, which is CloudWatch sample event EC2. And we're just going to paste in what we had from the past interface. So this is from the sample code from or from CloudWatch events. We're going to create that sample event, and now we're going to test it again. So this is just us manually testing it, and all it does is returns 200. It says, yeah, I got it. Don't worry about it. But in this case, it actually dumps out what we are seeing. So what we could actually do is make this a little bit cleaner. So let's make this cleaner. We can say print event detail type, print event details. So now let's save this and test it. And instead of dumping the whole event, I've just pulled specific attributes out of that document. So you'll see now we have, error because Mark can't type properly. Event details does not exist. Detail. Typing is not my strong point this morning. You should have seen the amount of issues I had. Not good. So in this case, what we've got now is we've got the detail type. It's an instance change, state change notification, and it's telling us the instance and the state. Seems like that works perfectly. So let's trigger this. Let's make something happen. So we've wired up. So just to review real quick, we got a few minutes left in the stream. Just to review real quick, what we've done here is we're trying to catch people making mistakes. And we know that the best way to do that is to prevent people from taking actions that they shouldn't be able to take in the first place. So in this case, I wouldn't give myself permissions to mess around in EC2 if I didn't need them. So if I wasn't supposed to be stopping or pausing or terminating instances, I should not have permissions to do that. That's the easiest way to stop a mistake or a misconfiguration from happening. Now, understanding that, shit happens. It's, to the end of the day, people make mistakes. It's going to be a problem at some point. So we have that slow lane, fast lane idea. We could use AWS Config for stuff where you shouldn't be doing it. But if you did it, it's okay. We can either bug you and say, hey, wait a minute, why'd you do this? Or we can correct it slowly. We don't need it. What we've done now is we've got something that's far more important. So a state change normally means you're taking a server or an instance offline, right? Or you're spinning one up. That costs money. That could potentially impact production. So what we've done here is wired up CloudWatch events. CloudWatch events looks at every action taken in your AWS account. And we added a filter. So what we did, and let me just review this with you guys. CloudWatch events. We're going to open that in a new link. All right. So for CloudWatch events, what we did here is we went into events, we looked at a rule, and we said, you know what? Every time somebody calls this API in EC2, so in this case, they're changing the state of an EC2 instance, trigger this function. So trigger this Lambda function called road to reinvent sample. And now our Lambda function, all it does is print out to tell us this was done because we don't have time to wire this up. But what you could put in this code here is actually to spin a new instance up, or to raise a security incident, or to take some other sort of remediated action that helps you to figure out what, or to respond to the incident. So a really common one that I help organizations set up is when something like this happens, to actually pull up the information of who made the request, to say, Mark made this request and he's not supposed to be able to check his permissions, right? And here's the permissions he's currently assigned. Here's the one he just took advantage of that he shouldn't have. Please, fix this, right? So there's really great ways to do that. So what we're going to do right now is back in EC2, we're going to take an action. We're going to go to instance state, and we're going to reboot this system. This system's doing nothing. It's just a demo account, so this is a low impact change. But we're going to reboot this. Yes, we're going to reboot. So this is changing the state because we're rebooting. Now this should trigger a console notification, and that just takes a few seconds. So if we come back into here, we are going to look at monitoring. And you can see the invocations. I think that's an extra invocation. This is the challenge with really low volume Lambdas, but we click on the logs in CloudWatch, and that's going to give us a better idea. Now, CloudWatch, unfortunately, again, has those three different areas. We have CloudWatch alarms, events, and logs. Now, this is not the latest log. You can see the timestamp is 25. Logs take a couple seconds sometimes to get kicked in. So we'll see if this actually triggered, or if the reboot might not be a trigger for the API call. That's a good thing to know too. So we'll just check in here. Yeah, this is just the standard demo that we had. So if we come back, all right, we're not getting that here. Challenge of live streaming. What we're going to do is go back in EC2, and we're actually just going to stop this. We're going to say instant change, stop. Yes, we understand. This is going to kill any data that's on the ephemeral disk. That is okay. This is just literally a random. So this is stopping. This will definitely trigger the API, and then we'll make sure to see that this worked all the way through. Fingers crossed. I don't know. So you can see that this flow, this pattern works pretty well. Right? Now the challenge here, so if you go this, and we'll look back at this slide again, if you have the fast lane, slow lane again, shoulds on the bottom, musts on the top. Really, really quickly here though, you can expand this out to cover a ton of different things. Now a lot of this is just sort of plumbing code, and it's not necessarily something that you want to trigger yourself. So this is where there's a whole tier of tools called cloud management tools. Horrible act. I don't come up with the names. I don't come up with the categories. But this is the whole goal of those cloud management tools. So we're not talking about like things like Chef and Puppet. Those are orchestration tools that help you set things up. There's a whole category of APN partner tools and other third-party tools to set up this kind of framework automatically for you so that you don't have to do the plumbing. So today we're in the weeds. We're doing a lot of the plumbing ourselves. Again, you can just get this as a tool, which is great. Because it's a lot of grunt work, and you don't necessarily need to do the grunt work. You want to do the value work, right? The value work here is figuring out what is important to you, right? So not flagging these things is not the important part. What you do after you flag it is the important part, and we're still waiting for this to come through. I have a feeling that I have a permissions error in here. And that might be a problem. Permissions errors are challenging, mainly because I co-opted. Oh, there we go. It actually invoked. Yeah, 13, 25, 26. Yeah. I'm pretty sure that invoked. We have a new graph with a line, and that's always a good thing. Extra invocation. I don't believe it actually triggered from the CloudWatch event, but that's going to be because we didn't set up all the permissions on the Lambda function properly. So we can correct that later on, but you guys get the idea here, right? If we run this test event again, you're going to see in the logs that it will have the proper thing where state change notifications. Oh, no, there it is. Woo, it hid. It just went fast. So there, it worked. Our state change of stopping, we actually triggered, right? Yay! I like when it works, especially when I've already backtracked and said it didn't work and I covered. So this is really straightforward. What we've done here is we've intercepted somebody doing something they shouldn't, right? So again, first case, ideal case is you don't give people permissions. You implement the principle of least privilege and they don't have the permissions to make these mistakes. But the reality is we're all human. There's challenges. People are going to make mistakes and misconfigurations. And the idea is slow lane, fast lane. Shoulds go into the slow lane. So stuff you're okay with and tolerant of being, you can put it through AWS Config, which bases off CloudTrail, which is a really nice visual way to give you that timeline of configuration changes, including third-party stuff. You can include third-party things in there with custom rules, and rules are just Lambda functions. Now, we did the fast lane too. We did the near real-time where we triggered from CloudWatch events. So when CloudWatch events fires off, we trigger off this Lambda, and it will take an action. In this case, all we did was just notify. We just outputted a log. This instance has been stopped, right? If we go back to EC2, you'll see instance E36 is stopped. If I fire this up and start it again, you're going to see another notification. We didn't take the additional remediation step. We're just showing you the hook, right? So that's the gist. That's the core. There's not a lot to this stuff. Like the concept is pretty straightforward. But you can imagine really, really quickly having a host of these rules and trying to manage that. And that's where there's third-party tooling available that can help with that overhead. But that tooling relies on the basic concepts that we saw today, which is really just figuring out what should not happen, what must not happen, and making sure you put that in the appropriate lane, the slow lane or the fast lane, and setting up the remediations. But if you can, again, same concept with AWS in general. If you can push the grunt work to something like a third-party tool, you're better off, because where the value you can provide your business and the value you have for your org is really in the remediation. What do I want to do if Mark does something dumb like setting a bucket to public or stopping a production server? Now, ideally, you stop that with permissions and you don't let me do that in the first place, but mistakes happen. And this is one of the ways, or a couple of the different ways, that you can actually correct those mistakes. And it's nice to build out this safety net. So as you can see from this stream, as you can see from other streams, Lambda is really critical to working in the AWS cloud. Even if you're not building production stuff in Lambda, you can build a lot of operational tooling in Lambda yourself. And again, there's a really robust partner network out there, an open source network or stuff, open source projects, and the serverless app repository from AWS that lets you get up and running with this stuff really, really quickly. But yeah, that's it for today. Hopefully that was useful. Hopefully that showed you some of the concepts of how to remediate and how to catch some of these mistakes and misconfigs. Let me know. Keep sending comments on LinkedIn, here on Twitter. I'm setting up the next streams for next week. As always, we're doing this, a couple times a week leading up to reInvent. There's 45 days left. As a reminder, now is a great time if you're going to run that charity run and have never run before. Start your couch to 5K. Excuse me, and you'll be all set come Tuesday for the charity run the week of reInvent. I believe it's Tuesday morning. If not, just donate directly to the charities. They're really fantastic ones. You can find that on the reInvent site. So let me know what other topics you want to see in this lead up. I really appreciate your time. Thanks for joining, and we'll see you on the next stream.